hand back the last papers, which would be openings, because I think I have everybody's at this point. If not at this point, they're just in the points. This should probably hang on.
Oh.
Anyways. Graph paper review. Hey, anybody seen? We gotta put them in secretary's basket. Let me look. Here's yours. I know, I'm looking at secretary's basket, which is probably what I did wrong. Franco's is there. Cyros is there. Anybody else not get theirs? No need for me to continue to dig for secretary's basket. Can we finish the opening? Can we look at what you got?
No.
Which one you on? Number one?
Yes. I think I know how to do it, but I don't want to start it and then it be wrong and then I have to redo it.
Oh, for the love of God.
All right. One where you put 64 over 7,020.
Sorta. You got to do the empirical formula first. Did you do the empirical formula first?
Why do I have to do that?
Because you don't have the empirical formula.
But I got the carbon, the hydrogen, and the ammonia.
Yeah, but you got to have an empirical formula to know what you got to add up. So let's do number one. All right, so you have 76.34 grams of something. Did I tell you what your grams are of?
Yes.
Yes. But did I write the formula for you? So what we got to do? Well, we're going to put it in a chart, but do I know what to add up when it's time to do my grams? Sodium dichromate. So how am I going to find sodium dichromate? Right. So how's sodium written? What's its formula with the oxidation number? Plus 1. And dichromate is what? Cr2O7. And what's its oxidation number? Minus 2. So bring our 2 down and our 1 down. All right. So now we have our formula. Now, I asked for formula units, right? So what has to go on top?
Moles.
Moles. Okay. So, extend your chart. What goes on the bottom? What goes on top? Formula units. Remember, we weren't going to say FU for obvious reasons. All right. So, from there, what do we put beside moles? Okay, so we're going to put a 1 beside moles. All right, so 1, and that's going to change later today. All right, what goes beside formula units or atoms, as Michaela said? 6.022 times 10 to the 23rd. And it's not an avocado, it's Avogadro. All right, and so for grams, what do we do? Of. Okay, so since we can't just look on the periodic table, we have to do what to that? Can we just look up this on the periodic table?
No.
So what do we have to do? Break it apart. So how many NAs do I have? How many CRs do we have? And how many O's do we have?
7.
Okay. So sodium has a mass of,
23.
and chromium is,
22.
and oxygen is.
16.
Okay.
Remember that?
So. You okay over there?
Yeah.
So we get 46. That should be what, 104?
Yep.
And I don't know, 7 times 16.
112.
112. So. So we get 262. So that's our mass right there. So 76.34 times 6.022 second EE23 divided by 262. So we get 1.75 times 10 to the 23rd formula units. Okay? Questions? Huh?
I said, thanks for reassuring me. I've done that test.
Okay. Oh, I need one more significant digit. So let me grab a 4.
Man.
Just lay it on my laptop and I'll mark you here, Jocelyn. All right. Now, for the one that Michaela was talking about in number 2. All right. She said that we had to divide this mass right here, 64, by something. And she's right. We do. But what do we have to have in order to divide? The empirical formula. Did I give you the empirical formula?
Oh.
We got to find the empirical formula. So what do I do to find the empirical formula? We got to change the percents to grams. So these are going to become G's. And what do I do with those once I have them?
Put them in a chart.
Okay, so 75 grams of carbon, 25 grams of hydrogen, okay. So I'm going to put what there?
Well,
No, we put them beside grams.
oh, well.
Yep, the mass on the periodic table. So we get 25, 75 divided by 12, 6.25. Okay, so when we do this, we have to do something to get whole numbers, right? So what do? Divided by the smallest. Good, Zara. So that'll be a 1. My best guess looking at that is that's a 4. Is that a 4? Okay. So the empirical formula is CH4. Okay, so the empirical formula is CH4. Now, at this point, we've only done half the question. All right, so if this is only half the question, what are we going to do with that 64 that's still in the problem?
You gotta break that. What was the question?
What are we going to do with the 64 that's still in the question to find the molecular formula?
You still use it, though.
Yep. Okay, so we got to divide. All right, we're still there when we got to divide. So 64 has to be divided by what?
So when you break up the.
That's right. We got to break this up. So C and H. So how many C's? How many H's? Okay. So times 12 times 1, we get 12. We get 4 for a total of 16. Okay. So 64 divided by 16 is how many? It's what? 4? That's what I got in my head, but I wanted some reassurance. All right, so 4 times CH4 is what?
C4 is 16.
Questions? This is what we did on that lab that we wrote down the names and everything. In fact, Franco, I think it's one of the ones you still got to make up. Okay? So see if you can't work that in your busy schedule sometime next week, maybe. Okay? Because even though that test grade wasn't all that stellar, I think if you made up some of those zeros, we could maybe get in the B range. Okay. All right, everybody caught up? All right, so we go back to number 3. All right, how are we going to find? You need me? They didn't ask me anything. I'm still here.
Okay.
All right, so number 3. What's percent composition? So Al2O3, what do we do if I want to find percent composition? All right, break it apart and do what? Add it together. All right, so we go to the board again. So how many aluminums do we have? 2. How many oxygens do we have? So times 54 times 16, 108, 48. Is that right? Yes, no?
How do you get 54?
Because it was well stupid, I already multiplied it in my head. Is that right? Huh? Okay, I already did the math in my head. Sorry. All right, so that's going to be what? 2 carry my 102? Yes? Okay. So, percent aluminum. How do I do percent aluminum? 54 by 100 and then times 100. All right, so percent oxygen is? Okay. I don't know why I changed colors, but okay. All right, and then you get your answers. Questions about how to do percent. Now, all 3 of those problems are in the Canvas assignment that's on the benchmark test that's take home. Okay? So, since Jocelyn's here, that only leaves us with 2 people absent. So, if you go into Canvas at some point on your own, you have until Tuesday at midnight to take the Canvas test. I can't remember if I said you could do it 2 times or 3 times. I think I said you could do it 3 times. All right, and it'll average the grade. It has a time limit of 70 minutes. I did not give you unlimited time. So when you sit down to do it, you need to have at least 70 minutes to do it. It has 37 questions. It's not an unreasonable number of questions to do. First of all, they're not all math questions, so it's not going to take you forever to do 37 questions. All right? It'll put 1 question on the page, answer it, do your thing, and move on. Some of it's naming, some of it's calculate, some of it's describe physical and chemical change, some of it's intensive and extensive, some of it's significant digits. It's everything we've done through yesterday, okay, on predicting products, telling types, that kind of stuff. The stuff we're doing today is not on the test, okay? Right now it's counting as a lab grade. I may change that to a test grade. I haven't decided, all right? We'll just see how we do. Any questions about that? But you have until Tuesday at midnight to do it, and then at some point the next day it should populate in the grade book. Everybody got that? Everybody understand? If you don't do it, you get what grade? It populates as a 0. Okay. So I don't want to hear anybody say I didn't know, and I'll try to remind you each day. All right, let's talk about this real quick. I'm not going to spend a lot of time on it. If you have a ton of questions or you want to talk about it individually, by all means, come see me. Trevor. Over there. This is over here. Franco's over there. Huh? Yeah. You go ahead. Here. There. Victor. Where did the Ali's not here, Ali's not here. Kayla. All right. Questions? Yeah.
So number 21, I literally do not know what I was doing. Like I tried doing that, could have bounced, I literally just couldn't do it.
Doesn't have the 14 right
Yeah, I got so annoyed, I just put a number that would make it make sense to me. Like this is just an answer, I figured out what to do.
This would have been a +4 and a -2. So you would have reduced it out of 2 there.
Yeah.
And that was a 7 and a 1.
I couldn't get that answer.
This would have been a 7. Okay,
Yeah, and I tried to balance it, I couldn't.
so if we pick something, I don't know what to pick, like let's just say sulfurs. So you got 7, so you put 7 times 2 is 14. So if we put a 2 there,
Yeah,
there's 4.
and then I put a 4 there,
Okay, so we got 4,
times 7 is what, 20?
28. So we need 7 lids, 7 lids.
But then, what? No, I refuse to believe that I didn't do that, because I did that on the plane for some reason.
I refuse to believe all day long that that's
I
all
think
about.
because I refuse to believe, I feel like I should get all those points back.
Anybody else? Question? Yes, no? You have lengthy questions, you know where to find me. Anybody?
What is the arrow with triangle on top supposed to mean?
He's that.
I literally didn't know if it was you or who's and it's like the conduit. You kept back in the answer.
You just no praise about that. You've been the DJ. I'm so disappointed it's like that right there.
I didn't finish it, literally, I just finished like this. You see, I went to the last one, because of the I just got open some of them. I'm sorry.
I know you just left blank.
Yes, you did. That's good.
Alright, so if I don't have any legit questions, let me have those things back.
Can I do it real quick?
No, you cannot do it real quick, you gotta do it on the test. You can't keep it. Done. Thank you. Thank you. All right, did I get yours? All right, Jocelyn. All right, you guys find your notes. We're gonna move on. We're gonna talk new stuff. Huh?
You taking notes?
Yes, we're taking notes. You're gonna need possibly all 3 charts.
What? Oh.
Oh, there it is. Start Jocelyn here. All right. Get rid of this. And
Wait, you saw all three like an observation sheet or?
yep,
Okay.
yep. All right, so this unit that we're going to do is really a culmination of everything that we've done since we started learning how to name formulas. So we're going to use the information that we've done on naming formulas, writing and balancing equations, converting grams to moles, and we're going to put it all together. Okay? So really for us, the test we're going to take next week is really sort of a benchmark because it puts everything we've done since about the third week of the semester all together on one test, with the exception of finding protons, neutrons, electrons, and some calculations with density and stuff. Okay? But being able to write names and formulas, being able to balance, being able to write and predict products, being able to convert moles, all of that is coming together in one word problem. Okay? So for those of you who are struggling to write equations, this unit's going to be hard for you. Okay? Those of you who really hate math, you're really going to hate this unit. Okay? And there's not a lot I can do for you about that. Okay? But the good news is, after we finish this next week, we're leaving math for about 4 to 5 weeks. Okay? That's the upside. So, for those of you who this is not your forte or your strength, maybe the next type of stuff will be. All right, so we're going to talk about 2 types of stoichiometry. This is really about 3 slides of notes, maybe 2 slides of notes, can't remember exactly. And after we do the 2 to 3 slides of notes, everything else is a word problem. There really are no notes to go with this other than learning how to work word problems. Okay? We have to learn one new skill, and then we have to learn to work word problems. So, composition stoichiometry deals with mass relationships between elements in a compound. Okay? So, mass relationships between elements.
What's that supposed to be?
That's what I'm getting ready to ask you. All right? Mass relationships between elements. So what kind of calculations have we done that explain mass relationships between elements to Franco? What kind of calculations have we done that explain mass relationships between elements? What have we learned to calculate so far this semester that were mass relationships between the elements in one compound? What? Molar mass. And we added up the mass of a compound. Okay, molar mass, you could call it formula mass, same thing, that's one. Give me something else we've done. Percent composition. All right, Michaela's now on mute. She can't add anything else to this. There's at least 2 more I want. Remember, calculating.
Oh,
So math problems we've learned. I'll give you a hint. We did them today. What kind of formulas? Yep. Empirical formulas. And molecular formulas. Okay, so an empirical formula took the percents of each element, right? And we figured out the compound formula. The molecular formula took the simplified formula and we figured out the formula before it was reduced. Okay, so that was a mass relationship between the overall elements. The other 2, we had the mass relationship by figuring out each of the elements and we added it up for the whole compound. Okay? That's what we've already done. Mass relationships between elements in one compound. Now, we're more sophisticated. You guys have learned how to balance equations, right? Learned how to write equations. So, now we're going to learn about reaction stoichiometry. All right? Reaction stoichiometry deals with mass relationships between compounds. Okay? So now we're going to do between compounds in a chemical reaction. That's what makes this different. So, we're going to do things like grams of sodium to grams of chlorine. Now, that example that I put up there will be late tomorrow. Okay, we've got to start easier than that. But we're going to learn how to change from one compound to a different compound. And we haven't learned to do that yet. Everything that we've done so far has been of the same compound. Okay? We have not changed compounds at all. It has been of the same compound. All right, has everybody had enough time to catch up? Princess, put your phone up. All right, you there?
Yeah.
All right. So, the only new skill we have is being able to find a mole ratio. Okay, that's it. Once we know how to write and find a mole ratio, we're only working word problems the rest of the time. Okay? Because you have all the other skills to do this. We're just blending the skills that you have. Okay? So, what is a mole ratio? All right? It's a conversion factor. It lets us change from one compound to a different compound. That's all it does. All right? It's a conversion factor that allows us to change from one compound to another compound. It's its only function. So, when we work a word problem in this new unit, if we're changing from one compound to another compound, we will have to have a mole ratio. You cannot work one of these new problems without a mole ratio. So, we need to learn how to find moles in a balanced equation. And this is one of the easiest things we do. Okay? So, we need to be able to balance an equation. Now, virtually no one balanced anything like this wrong on the test yesterday. Okay? Virtually no one. So, when I look at that equation, what is the first thing that you guys balanced on the test yesterday if you had that equation? Most people would have done the O's. Y'all would have done this long enough that most people probably did the O's first. So you would have said there's how many here? And how many here? So you'd have said 3 to make 6. And you'd have said 2 to make 6 O's. Now, when you did that, you made how many FEs?
4.
So you put a 4 there. Now, these coefficients tell us something that's very important in this unit. Okay? The coefficients tell us the number of moles. So, the coefficients equal the moles. So, if I want to know the moles of iron, there are how many moles of iron? There would be 4. There would be how many moles of oxygen?
3.
What tells me the moles of oxygen? The coefficient. So it's 3. Now, when we first start this, people want to do what Elijah did. They want to look at it and they want to say 3 times 2 is 6 because we've been counting the number of oxygens for so long when we balance. But when we do moles, we're not counting the number of oxygens to get the 6. The coefficient is strictly the number of moles. So there's 3 O's, so our number of moles is 3. So how many moles of iron 3 oxide are there? There's 2, okay? So when we count moles, we're not actually counting the number of atoms. We're simply looking at the coefficients. Does that make sense? Yes?
Yeah.
Okay. So if we want to write a mole ratio, a mole ratio is simply putting one compound on top of another compound, okay? So, Gerardo, pick one of those compounds out of that equation. There's only 3. Pick one.
The 3O2.
Okay, so 3 moles of O2 goes on top. Janiyah, pick a different one to put on the bottom. All right, 4 moles of Fe. This would be a mole ratio. Okay? We put one compound on the top. We put one compound on the bottom. Okay? It's that simple. So if we write a different mole ratio, give me something different on the top, Zaria. 2 moles of. Okay, come on, babe. Miss Wall's going to turn 50 next month. My hearing is the first thing to go behind my eyesight. So say it loud enough I can hear you.
Fe.
Yeah? Keep going. What's it say? Fe2? Yes. Very good. I like that. Excellent. All right, Zariah. Did I say it right?
Nope.
Zyra. All these Z names in here are killing me. All right. Zyra. All right, give me something to put on the bottom that's not the 2 moles of Fe2O3 since we already have that. What? Sure. All right, that's another mole ratio. All right. All right, Princess, give me something to put on the top. I don't care what. What? All right. So 4 moles of Fe on the top. All right, give me something to put on the bottom, Serenity. Sure. Okay. Now, some people would say this one and this one are the same. Are they the same? No, they're flipped. They're opposites. Okay. Questions about how to write a mole ratio? Think you can do it? Sumatra's going no. All right, Sumatra, let's write one. All right, give me something to put on the top. All right, let's put something on the bottom. All right, so since you said that, what's right in front of it? So we write 2 moles of Fe2O3. You just wrote a mole ratio. Seems to me you got it. You okay? All right. I want y'all to write any 3 you want. And then I'm going to make you come up here and write some on the board. Oh, my gosh.
We gotta balance it first.
Well, I don't think I need to balance it.
Oh, see, you couldn't have given us one of those already.
I did not give you one that's hard to balance.
I know, I just said that.
Those people who wrote that equation right on the test balanced it right.
Oh, okay, this one I'm supposed to start with this. Oh.
Oh, yes, that's right.
Three, or wait, how many did you say, right?
So right there.
Oh, I'm so sorry.
So what now?
Can you reduce some more ratios?
Yes,
Why?
but why would you? I mean, you could theoretically, but there's no point in it. Just leave them the coefficients as you have. Okay? Even when we do the stoichiometries and they're like that in the chart, let's say that you forgot to reduce your balanced equation, I won't even take off for here because it'll take care of itself in the chart. All right, you got some? Feel like we're good? Daniela, you want to put one up there? You want to put one up there? Yeah, you do. Come on, you feel brave. I have great confidence in you. You can do this. We'll help you. I'll help you. Remind me of my daughter. Nope. I'm not going. Call somebody else. You're all correct. Choose anyone you like. Yep. All correct. Good. All right, Grady's going to put one up there. Five rules. All right, how about Gerardo? No, Kayla, I'm not calling on you. You'll talk to me.
What'd I do?
You'll talk to me, so I don't need you to go to the board.
I was well, wait, what was I talking
Anything, when I call people or ask questions, you'll answer me. I gotta call these people who won't talk to me.
about?
So is that the amount of avocados? Avocados.
Good. All right, how about, Trevor? This way I can report tonight that you're doing good work. Good. All right, there's four. All of those could be flipped, and there's probably others we could put up there. Everybody okay on how to write a mole ratio? Yes? Okay. Now, for those of you who are like, they get Sumatra, who always wants titles. All right?
Yes.
All right, you see number 2 up there on the board? No, 3. 3 on the board? It says mole problems. That's your title. Okay? Because these are not titled. All right, so these are going to be mole problems. Now, for those of you who want to save a little writing because you don't like to write, you do not have to write this part right there. Okay? You have to write the equation and the part below the equation. All right? So I'll give you a minute to write the word problem.
You just said we don't have to.
You have to write the equation and the problem under it.
Oh.
But you don't have to write the part about the spacecraft. Okay. Okay, but the title is mole problems. And you have to write the equation and the part about how many moles of lithium hydroxide are required. That part you have to write. That's the question. But I don't care if you write about the spacecraft and carbon dioxide is exhaled by astronauts to be removed by the reaction with lithium hydroxide. That's just sort of extra. Now, when you finish, balance that equation. Sometimes this one causes issues for people because there's oxygen in all 4 compounds. And some of us had issues with equations like this on the test. So try to balance it without me first, and then I will balance it with you. Okay, and then we'll work the question. All right, but see if you can balance it without me. You okay over there?
Yeah. I'm gonna do this in three because I know this one.
Okay. You have a pencil?
Yeah.
Okay. No, you don't have to write moles under it. No, I just want you to balance it. See if you can do it. Sometimes it hangs people up, so I just want to make sure we're not hung up. We got it. Need me to balance it? Where we at? Hang on. Okay, I can hang on. All right, we there?
Yeah.
All right, so if we look at it, what should you balance first?
Oxy. Well, that's nice.
I would do lithium first, okay? Because there's how many lithiums right here on the right? There's 2. All right, so since there's 2 I's, I would put a 2 there to balance my lithiums. All right, so 2 lithiums, so that takes care of that. How many C's? How many C's? How many H's? How many H's? So we're down to the O's, right? So how many O's are here? How many O's are here? So 2 plus 2 is, there's 4. How many here? How many here? So 4 and 4. So all you need is a 2 in front of the LIOH. Okay? Questions? All right. So how is this question different from the ones we have been working?
It's not.
It is.
Oh.
It says 20 moles of CO2, and it wants you to find moles of lithium hydroxide. Now, if I pull the opening from today back up, in question 1, it said how many, let's just say it said how many moles of sodium dichromate. The only compound in question 1 was sodium dichromate. It never said anything about another compound. It said sodium dichromate. This question has how many compounds in the question?
2.
2. All right? Now, whenever there are 2 compounds, that alone tells you you're going to need a mole ratio. Okay? Because will I always write the equation in the question?
No.
No. That's why we learned in the last unit how to write and balance the equations. Some of the questions I will have given you the equation for. Yes. Will I do it on all of them? No. Sometimes I'll only write half the equation so you can predict the other half. Some of it I won't have written any, as you'll see shortly on the next question. Okay? I don't remember if I wrote it on the next one. Nope. See how nothing's there? You have to do it all. All right? So, what are we going to do? Same thing we've always done. What have I given you in the question?
20 moles of CO2.
Okay, so I'm going to write 20 moles. Write it a little higher. 20 moles of CO2 goes on the top line of my chart. Now, this time, I'm going to make sure, I write my compound on my chart because we're going to have to change compounds. So I need to make sure I know which compounds I have. Okay? Now, every time we did this, whatever was on the top line had to go where? On the bottom. What was the reason for that? So it would cancel out. So I'm going to put moles of CO2 on the bottom. Now, for right now, I'm going to write stuff under it so we understand what's supposed to go through our head. We're not going to do this all day. All right? Are we changing compounds? All right? So, what did the question ask us to do? It wants to know how many moles of lithium hydroxide. Well, it wants lithium hydroxide, right? I'm in what? CO2 is called what? Carbon dioxide. So are we going to need to change compounds? I see several heads nodding yes out there. So if you answer yes, all right, if yes, put moles on top. So I'm writing moles on top. if you have moles over moles, that's called a what? What did we learn that was called just a minute ago? If I go back right here, what were all these moles over moles called? It's a mole ratio, right? That's a mole ratio. So if that's a mole ratio, what do we, thank you, my dear. What do we put next to those moles? Coefficients, okay? We're going to, let me change colors. Okay? We're going to, first of all, change, let me make that go up a little bit. We're going to change the compound, and we're going to use coefficients. Okay? So anytime we have moles over moles, that's a mole ratio. So the two things that we've learned today that mole ratios do are to change the compound and to use the coefficients. So what compound did the question ask us to change to?
Lithium hydroxide.
So we're putting LiOH on the top. It gave us CO2. It wants that. These two are irrelevant. We don't care about them. They didn't tell us about it, doesn't ask about it. So the numbers that go beside it come from where?
The coefficient.
So what coefficient is in front of LiOH? So we put a 2. What coefficient is in front of CO2? So we put a 1. That is all we do. Okay? So to calculate, what do? 20 by 2, and we divide by 1. It's irrelevant, but that's what we would do. So we get 40 moles of LiOH. So what?
I just multiplied whatever it got CO2 to 20, and then multiplied that by the 2.
Just the coefficient.
Yeah.
That's okay. That's what we did.
That's okay.
It's more complicated.
Because she got to explain.
Right,
it.
it's just because she explained it. If she
I'm
didn't
just
explain
explaining why we multiplied by 2. Because these charts, these are 2-step charts. We're going to grow them to 4-step charts. Zaria. Yeah, I'm going to do 2 more. Okay? All right, let's try another one. In this one, you need to write all of it.
Ammonia.
Now, you see how ammonia is up there, and I told you the formula's NH3? You got to memorize this one.
Why?
Because nobody's getting out of here unless you learn ammonia. For goodness sakes. It's a common household chemical that everybody in chemistry knows. It's sort of like knowing salt by the time you get out of here, or water, and not knowing the formula for salt or water. Ammonia is another one of those. Huh?
Is ammonia just pee? I need pee in my house. Pee.
Urine.
Yes, I'm aware of that, and no. That's why I'm looking at you like, no.
So why do we need, okay.
I mean,
So what am I writing?
if ammonia was just pee in a bucket, and you
Right.
use it to clean your
Yes.
floors. Do you want to mop your floors with your pee?
No.
Then I don't think ammonia is just pee.
So what's ammonia?
It's a household cleaner. It's NH3. That's just the formula for it.
Oh my God.
I mean, I'm not telling you there's not some ammonia in pee, but pee also has other stuff in it besides
My
ammonia.
body expels bleach.
No, don't mix bleach and ammonia.
Yeah.
It creates a toxic gas that can knock you out.
Oh, love that.
Huh?
Right. What's
Till
that
you're the
thing?
one laying on the bathroom floor because you mix too much of it.
What's that thing that people knock you out with when they're trying to take you? Like with the napkin? Chloroform.
Chloroform?
Not chloroform. Chloroform. Is that the same thing?
Huh?
Is that chlorine and
No, chloroform is not from bleach and ammonia.
oh my gosh, I forgot.
What do you buy from the store that's-
Huh?
What do you buy from the store that's
That's ammonia?
Yeah.
It will usually say ammonia on the bottle and household cleaner or something. You can buy generic. You can buy something that's probably a name
That's
brand. You can buy Windex that says it's got ammonia in Windex. lots of things have ammonia in it, but it will say it has ammonia in it if it does.
And spray some algae down there.
It depends on how much ammonia and how much bleach you put together. It's not a good combination.
Is ammonia itself toxic?
Ammonia itself,
I don't-
not in small quantities. I mean, you shouldn't mix it in large quantities. Now, if you buy fertilizer, which has ammonium hydroxide in it, that's what they used in the Oklahoma City bombing back in
Well,
early 90s. I can't remember, 91, 92, 90, 89, somewhere around in there. And they blew off the front of the federal building and killed 100 people, maybe, might be a little less than that. But now, because he bought fertilizer to do that, they track people how much fertilizer they buy, and then if they buy it in large quantities. They investigate why they need that much fertilizer, particularly if you're not a farmer.
Oh my god.
Wait, oh my gosh, you know what I'm terrified of as well?
Why?
Anthrax. Oh my gosh. What if there's another anthrax attack? We literally can't do anything. We're all gonna die.
It's possible.
What is anthrax?
It's like a powder that, like, if it gets in your vicinity, basically you're dead. Because like if you breathe it in, your life is over.
I'll see it when you see it.
They put it in the HVAC unit here. We're all dead.
Oh, I thought you said they do put it in. I'm like, hey,
I
bro.
said if they put it in the HVAC unit.
Where
What are we
everybody
talking
can.
about?
How do they make that stuff? Anybody can make it. Well, make
Well, if you know how, I don't know how. You know how to make anthrax?
I'm gonna learn how to make anthrax.
Okay.
So
I was gonna say, I don't know how.
I should have done
I'm like, I just do the.
All right, so when you look at the equation, or the question up there, I gave you color-coded parts to try to figure out the equation, okay? Now, I'm not gonna do that on the test.
Yes.
You should do it.
Okay, people, I have a black and white copier back there. We are not wealthy enough to give you colored copies on the test. Secondly, no, that will not happen. Even on the state test, you're getting black and white, which is on the computer. They're not color-coding anything. So, what does it tell you is produced up there? Come on. All right, so what side of the arrow does it have to be on if it's produced? Has to be on the right side. So NH3 has to be on this side of the arrow. All right, so what is it produced from? What does it say it came from? When hydrogen reacts with an excess of nitrogen. Now, does that excess part mean anything? What reacts with what? Hydrogen reacts with nitrogen. So we write H plus N. All right, so H plus N. Do we know anything about H and N?
Two.
They both get twos. They're both one of the 7 diatomics. And there's your equation. Okay, so you have to use what we've already learned. So, is it balanced?
No.
No. So who do we want to balance first? Okay, so H has how many?
2.
And how many here?
3.
So I'm going to put a 2 to make 6. I'm going to put a what here? All right, how many N's?
2.
How many N's?
2.
Fabulous. All right, so what do we know from the question? What did they give us? How many moles? 6.0 moles of what?
Hydrogen.
Now, if you're not sure what they gave you, find the number. Okay? See how it says 6? And right behind it, it'll give you the unit and the compound. So 6 moles of hydrogen. Okay? So what goes on the bottom? Moles of hydrogen. Okay? So it'll cancel. So what are you asking yourself? Okay? Are we changing? All right, what they ask us to find.
Wait.
Find your question. The who, what, where, when.
Ammonia gas.
How many moles of ammonia? So is ammonia the same as hydrogen?
No.
No. So we're changing compounds. So if we're changing compounds, what has to go on top?
Moles.
You got to put moles on top. All right, so this right here is our mole ratio. See how we got moles over moles?
Yeah.
So what 2 things did we learn we could do here? Okay, so we're going to change the compound. And we're going to do what? We're going to use the coefficients.
Oh, in the balancing.
Okay? So, what compound are we changing it to? What did it ask us to find?
Moles of ammonia.
Moles of ammonia. So, which one of those is ammonia?
NH.
NH3. So, we put that on top. All right. And when I have moles over moles, where do the numbers come from?
The coefficient.
So, what's in front of ammonia?
2,
And what's in front of H2?
3,
So 6 times 2 is,
12,
divided by 3 is.
4,
Now I need 2 significant digits, so I need a what behind it?
0.
0.0. Questions? It's not hard, is it?
No.
No? All right. You don't have to write this one down. Let's just do it. You've got 2 examples. So let's just work this one. All right. So we're going to decompose KClO3. Do you remember how to decompose?
No.
So where are we going to look when we decompose? Because most of us probably don't remember what it makes. So where do you look?
Oh, you're a child.
On your chart. So find your decomposition chart and look it up. What letter is it? All right, I hear some E's out there. What about the folks in the back who are just flipping to it? Check out E and see if you agree with Franco and Michaela. Do we think E is right? Yes? No? All right, I got some nodding back there. So we've got MClO3. So what do I get? MCl plus O2. So what goes in the M spot, Samantra? What goes with M? What? Okay. And then I put what with it? And then plus what? Very good. All right, so I can get rid of this. And I need to check my oxidation numbers. What's K's oxidation number? And Cl? So those cancel out. All right, so to balance, I have a 3 and a 2. So 3, 2, and 2. All right, what did they give me in the question? All right, so see how I found the number? Trevor said 15 moles of oxygen. Are we with him? Okay, so we put that on the top line. All right, what goes on the bottom of my chart, Xavier? Whatever's on the top has to go where? That's right. Moles of oxygen has to go to the bottom, so it'll do what? All right, now, what are they asking me to find? Princess, what do they want me to find? Find the question word. All right, moles of potassium what? Chlorate. So what unit am I putting on the top? All right, so if I'm putting potassium chlorate, what unit do I have to put on top? If I want to change compounds, I have to put what? I heard it. I have to put moles on there. That way I can put ClO3. Okay, if I want to change compounds, I have to put a mole there. All right, so where do my numbers come from? Who didn't I talk to? Victor, where do I get my numbers from?
From the equation.
From the equation, the coefficients. So KClO3 has a 2, oxygen has a 3. We get 30 divided by 3, which is 10 moles of KClO3. And I need 2 significant digits, so what am I going to do? Put a what? Put a decimal. Putting a decimal will give me 2 significant digits. All right, we're going to practice for just a few minutes, and then we're going to learn the second kind of problem today. One, 4. Serenity beside you, Xavier.
Are we done with
This
no?
one's for Elijah.
For the
No, we're not done with notes. We got to learn how to do mole gram. 1, 4, Danielle.
Thank you.
All right. right, on the side that says mole, and there's one for Trevor. All right, do as many as you can before I stop you on 1 through 5. I'm not going to give you a lot of time though.
Here.
All right, the equations are written, so you have to do what? You got to balance and then draw your charts. So we don't have to write any equations. So, if I have a question? Sure. You got there? Okay.
Oh, shh.
Yeah.
Oh.
Don't spend your time just balancing the equations. Actually, do the chart. Yes, my dear.
So I'm supposed to use this substrate of potassium.
Okay, so this is potassium hydroxide, which will be that one, right? Right, KOH, not just K.
Um,
And so that would go to the bottom, so it cancels. And then what are you going to on top?
iron.
Yeah, iron, which one? So which one of the, yeah, that one. Yeah.
Does this one not matter when it say reacts with iron?
Doesn't matter.
It does?
When it says what it reacts with, nobody cares.
Oh.
You're only interested in how many moles of. Yes and no. The answer's gonna be right, the mole ratio is right, but see how it says how many moles of iron 3 hydroxide? You wanna go to this, okay? See how it says it reacts with this? Nobody cares about that, so you want it to go to iron 3 hydroxide, so change that to this.
Is this the right answer?
Yes. Yeah. Yes? Right chart? Yeah, balance is a right chart. So I'm actually always over here on that side. Make it easy for you. Yeah. Yes. Now just imagine, for just a second, if A, you were absent, and B, you came to class full time, what you could do. That's with missing the most class, and you got it right. Imagine.
Right, so then how do we make it correct?
Why are you on the gram side?
There's another side?
Right.
No, you handed it to me like this. You
Dude,
did.
and I said,
But we didn't even.
mole side.
I. Yeah, let's get these right. This one right. Wait.
You did. If you did, that's fabulous. Now do the right side of the paper. Is everybody else on the mole side?
Yes.
Okay. I thought I said it, but.
You got the grade?
I
I just want these.
It's a symbol for potassium.
I didn't do that. I mean, I put it in that tray and I just put the color and it was all.
What? Which one is propane?
The only one that you don't know.
Oh. Okay. Number 4 is access to number 3, but instead of option, do carbon dioxide. All right. We good?
This way.
The opposition.
Hang on one second. Yeah. Doesn't matter. Does not matter. The equation's written. All right, you have 3.8 moles of zinc, which you wrote zinc, and you're finding how many moles of copper. Which one of those is copper? You just write copper. Doesn't matter what the oxidation numbers are. The equations are written. Who cares? It's already balanced. You won't put parentheses around the SO4s on both sides. Make it easier on the back. So there's one outside, one outside, so that's balanced. One zinc, one zinc,
I said yeah.
copper.
But he was like,
Correct. Correct.
Yeah.
Okay, you get these two out right there. Yeah. You go up there, so that notebook is farthest to the right, flip till you find that sheet you can do. Yeah, the big fat notebook. Yes, yes. What?
oh shoot.
Okay. If anybody's in number 3 and you're lost about what's propane, tell me what H2O is.
Water.
Okay. What's CO2? Carbon dioxide. What's O2?
Oxygen.
So which one has to be propane? The other one. Go.
Hey,
Zaya.
this one? No, the other. This one?
Yes.
Oh.
Okay, turn the pages. You get to. No, the other way. Yep. There you go. Keep flipping till you get there.
Oh, okay. I was
Okay, so put that on your chart. No.
number 1. I got 2.25.
Yeah.
Oh, I'm supposed to write.
Yeah.
Yes.
Both of them.
Oh.
I put a 0 behind this.
Charles.
Okay. Yeah, that's what I got.
They're right. What? Did you got it right?
Yeah. 7.2.
No. You're not necessarily gonna have whole numbers. No. Don't do anything about it. All right. Did you find the file?
Yes.
Who wants to use this? Yeah. All right. Has everybody made a good start? Feel like we're getting okay with this? Yes? No? Yes? Because I really want to start talking about that other kind of problem. What's wrong? That should be a 5. 6 and 4 is 10, so this should be 5.
Wow, this is long.
Does that make sense? Okay. All right. So let's talk about the new kind of problem. All right. So if you're Sumatra and you gotta have a title, it's number 4. Okay. Mold grains. Okay. Mold grains. Okay. And I'll let you write that problem down.
All of it?
Well, because the problem, the way to write the equation is tangled in the word problem.
You said, oh, this is, wait,
This is a new problem.
it's on her sheet.
Somebody said flip to the other side.
No,
You said that? Pretty sure.
pretty sure I didn't say flip to the other side.
You said mobile gram is the.
I said momogram is the title, and I said you had to write the word problem.
Oh, well, my bad.
Yeah, right now I'm losing my mind.
Me too.
Maybe you guys should just retire at the end of this year.
Don't.
We not gonna have her, you don't teach any other classes, do you?
What?
What do you
But
take?
I'm always-
What do you take after
Like,
chemistry?
I don't teach anything else after chemistry. I see you retire.
So I guess you can.
I am losing my mind.
Yeah, but if you retire, then Miss Red's gonna want to retire.
Well, I don't think.
Michael, you're literally gonna leave, so it doesn't.
I'm saying if she retires at the end of this year.
Miss Rector's not finna, oh, Miss Wallace, let me retire right now.
Right, she can't. You gotta give them like a notice or something, don't you? Unless you just
What are you
quit.
doing this right
Just let them off.
Unless you just quit.
Yeah. Yeah, I don't think you get your retirement stuff.
I think I have to give them 3 months' notice to make sure I don't lose a paycheck.
Oh.
So Mr. Tillman said that rumor is y'all might not be getting paid on Monday.
Oh, yeah.
Is that true?
That's what.
No, according to the school board
They
meeting,
fixed it.
because I watched that. The way that works is they move money from pot to pot to the paycheck pot. So the federal funds have come in, so they'll take money out of different pots of money, because the way education works is everything has a different pot or budget line. And so they'll take money out of one pot and move it to the payroll pot to pay us. And then when the state monies come in for pay, they'll move it back to the pot they took it out of to pay us. No, but we will get paid on Monday. I watched the September board meeting just to make sure that we would get paid.
Would you finna show up if y'all didn't get paid?
Huh?
Would you show up even if you didn't get paid?
That would be an interesting conversation because I'm not a volunteer.
Right, I
I
would
mean,
not.
I'm not donating my time.
I would not.
I mean, I have a house payment to make, utilities, those kinds of things. Groceries, my kids expect to eat.
Sue.
So I hadn't really thought about what I would do if I wasn't getting paid. I just, assumed that there will be a paycheck in the bank Monday.
It better be, we going on strike.
All Monday, they're gonna go on strike for you guys.
Right.
Never had that experience.
I wish I was.
All right, so if we look at the question, what does it tell you is produced? Okay, so it says in the question that glucose is produced. Okay, see how it says glucose and oxygen. So on the right of the arrow, C6, H12, O6 plus oxygen is produced. Now, what does it say it came from? Okay, so it came from carbon dioxide and water. So carbon dioxide is CO2 and then plus water. So we're going to take and balance it. Now see if you can follow my thought process here. All right, how many C's are here? So we're going to put a 6. How many H's are here? So we're going to put a, okay. Now, the O's are where people have a hard time. This is where I'm saying, see if you can follow my thought process. So I have how many O's here?
6.
And I have how many here?
6.
So those two are balanced. How many O's are here? 12. So I need 12 here. How do I get 12?
That's so crazy.
Okay? Now, this problem gives us what to start with?
This is the devil's problem.
CH3.
Like I said, find the number. The number says what?
3.
3 moles of what?
Water, H2O.
So we're doing the same thing we did a second ago. What goes on the bottom? What'd you just do?
Okay.
Okay, so nothing's changed there. So you're asking yourselves, are you changing compounds? What's the question? Mass of what?
Glucose.
Glucose. That's this thing, in case you forgot from biology. Okay, so are we changing compounds?
Yes.
Yes. Okay, so what do we put on top? What did we just learn?
Moles of glucose.
Okay, put moles on top. So that means we're going to have a mole over a mole. So what's that mean we're going to do if we got moles over moles?
Coefficient.
Okay, we're going to use coefficients. That'll be number 2. Okay, what's number 1? Change the compound. Okay, so we're going to change the compound and we're going to use the coefficient. All right, so we got mole over mole. What compound are we changing it to? What does it say? Find the question word. What mass of?
Glucose.
So we're putting C6, H12, O6. And now we're using the coefficients. What coefficient does glucose have?
1.
What coefficient does water have?
6.
Now, that's what we just did.
Yeah.
We were done. This question wants what?
Mass.
What's mass always mean? So we're going to add another section. Okay? What has to go on the bottom? Moles of glucose. Whatever's on the top has to go to the bottom, so it'll do what? Cancel out. Now, from there, you can ask yourself, are we changing compounds again? But the answer is going to be what? This time the answer is no. We already did it. Since we already did it, we don't need to do it again. So, when you have moles and grams, oops, I wrote that backwards. Hold on. Okay. Moles and grams, you put the same compound. So, what's the same compound going to be?
Glucose.
You're putting glucose back up there. Now, this is the conversion we've been doing since week 3 to 5. What always goes with moles? 1. And this is that 1 mole equals mass. That's why we put a 1 there. So, how are we going to get that mass?
Gotta break apart. This is too many steps.
Yep. You got to say C equals 6,
Oh.
H equal 12, O equals 6, times 12, times 1, times 16,
How many questions?
72, 12, 96, 180. Okay? You have to do all of that. So, 3 times 180, well, that'd be 2. That'd be 0.5. 180 divided by half, that'd be 90. And I need 3 significant digits, so 0.0. That's what you would get. You with me? I said 3 times 180 divided 6. I just did the math in my head because I can say 3 divided 6 is half. So half of 180 is 90. It's mental math. because I couldn't do 3 times 180 because I didn't know that. Okay, now for homework, I want you to finish the front 1 through 5. If you already finished the front, great. On the back side, I want you to do, I want you to do 1B, 2 and 3. Okay, 1B, 2 and 3. On the front, finish it if you didn't. And on the back, 1B, 2 and 3. Everybody got it? Fabulous. And tomorrow the desk will be back where they belong, because I'll fix them after 4th period. Does their normal test.